So our next two speakers flew in from China to give us a really interesting talk. Bing Lu is the assistant professor of data and computation at Duke Kunshan University. And what I really like about his lab is I think he's one of the leading labs in China in the domain of federated learning, and he likes to use Flower. He's going to be telling us how he and his student Stephen are going to tell us how they're going to build out this vision of a FedCampus. So there's going to be a smart campus. There's a smart campus that is built on privacy-preserving infrastructure using federated learning techniques. So thank you for coming so far to give us this talk, and over to you.
Thank you, Nick. Hello, everyone. Really happy to be here and present our project, FedCampus, at Flower AI Summit. So join me here today is my student, Steven. So, and I don't know whether he's the only undergraduate student here in this room. So he's a senior student, probably he will join a PhD program this fall. But he haven't decided which PhD program yet. So, okay. So for today's agenda, so in the first half, I will briefly introduce some of the federated learning research work I have been doing, and also my group has been working on. And then I will briefly talk about the FedCampus project overview. And in the second half, Stephen will take over to talk about the system development part in FedCampus. Basically, he will introduce 3 key challenges in terms of the system design. Okay, so Duke Kunshan University. So here, probably you may not heard about this university. It's quite young. So it's been established in the year 2013 in Kunshan. So it's as a U.S. and China partnership between Duke University and Wuhan University. So one of the key features of our university is that we will offer Duke degrees, both graduate and undergraduate and graduate degrees. So, a couple of words about my lab. So I lead the DKU Edge Intelligence Lab. So my research interest mainly about federated learning and analytics, and also AI-powered mobile and IoT systems, as well as game theoretical, like computational game theory and incentive mechanism design, especially in federated learning. So those clients, they are not belongs to the company or the system. So you may need to design the incentive mechanism to attract the clients to join your federation. And so the research in federated learning in my group is mainly focused on how to address the challenging statistical and also system heterogeneity, because those two heterogeneity are coupled in terms of the different clients. So when you design your algorithm, you should consider both the data heterogeneity and also the system heterogeneity. System, I mean, like different clients, they may have different computational power and communication power, and also the unstable issues. So, so here, this slide summarizes some of my research overview in federated learning. So our goal is to enable effective and efficient federated learning at future network edge. So when you deploy federated learning at future network edge, so how to make sure the model works, which means effectiveness, and also if it works, can we do it more efficient way? So here, efficient, we mean both time efficient and also energy efficient. So some of the works like using the methodology like optimization from system parameter control to make sure when you deploy federated learning algorithm, you can achieve both time efficient and energy efficient design. And also adaptive client sampling, focusing on different clients, they may have different priority or importance. And third work is about incentive mechanism, right? So how to attract, how to incentive those clients to join federated learning. So you need to consider, if we want to design a mechanism, you really need to consider different clients, what is their contribution level to your effective learning model. So you may design different price, different payment strategy for different clients. And also different clients, they may have different interests about joining effective learning. If I really care about this model, I may join without even you pay me, right? But if I'm not really care about this model, but if you want to use my data, you want to use my training resources, so you need to pay me. So this is about incentive mechanism. And last work, this is really about today's presentation about FedCampus. So instead of theory and game theory works, we also we have also done some system development in terms of application app. So FedCampus. So the overview for FedCampus is what we really want to achieve is we want to analyze our university's health data in terms of both students and faculties. For example, we want to analyze what is their sleeping patterns, their exercising time, what is their pressure in terms of heartbeat and the heart rate. So related to the anxiety and pressure. So this is related to the health data. Other applications we have been doing is try to analyze in the campus level what is the heavy hitters like the popular words, popular song, and also some GPS-based heat map like the different populations trend. So that's the basic overview of FedCampus. So our project wants to target two kind of audience. So first, the users, like the students' point of view. From the students' point of view, students may interest about others, like peers' behavior, without revealing its own private data. And also, another perspective point of view is from the administration of university level. So the university may want to know students' health and well-being conditions, like the anxiety and pressure variation during exam period and before the exam period. So that they can adjust like the teaching load and make some suggestions for faculties. So that's the two target audience. So here's the short video which really captures the FedCampus.
As a student, that's intriguing to see how my fitness data compares with my peers. When do they sleep? How long do they usually spend in exercising? For university administrators, tracking health trends and ensuring students' well-being is crucial. How are students' pressure level and sleeping pattern vary, especially during the exam period? How can we analyze and learn population's health data while protecting individual sensitive and private data? The challenge is to comply data privacy regulations. To address data privacy challenges, here comes in our FedCampus a privacy-preserving data platform, a smart DKU. With privacy-preserving technologies, differential privacy in federated learning. Differential privacy carefully perturbs sensitive information while providing valuable statistics trends. For example, when comparing your sleep quality with others, differential privacy ensures that individual sleep patterns cannot be traced back to a specific user, unlike traditional methods where user data is centrally analyzed. Federated learning enables FedCampus to leverage multiple devices like smartphones and smartwatches for decentralized data processing. By analyzing data from various sources, FedCampus can tailor fitness recommendations aligned with your health goals. You get the benefits of customized fitness device without exposing your sensitive information. Supported privacy-preserving techniques. FedCampus is your personal health assistant. It prioritizes and respects your privacy, empowers you to make smarter health decisions. With FedCampus, you can monitor your daily health metrics to know your ranking in the population statistics without privacy leakage. FedCampus also provides a feature to view your percentile rankings with privacy safeguard in areas like daily steps and carbon emission reduction, supporting sustainable campus lifestyle. FedCampus also features comprehensive overview of the campus health statistics. After our several rounds of lab internal tests, we successfully launched our FedCampus project at DKU and distributed 100 smartwatches to volunteer students and faculty, empowering us to build a privacy-preserving health data ecosystem at DKU. As FedCampus evolves, we aim to build a privacy-preserving data ecosystem.
Okay, so that's the video, and so before I introduce my students, so here, so I want to share that this is the reason why normally I will wear 2 watches. So that when people ask me, okay, why do you wear 2 watches? So I can introduce our project. Okay, so now, Steven.
Thank you. So I think I have 4 minutes. Let's go look at how the implementation of federated learning in FedCampus works by boiling it down to 3 challenges, really. The first challenge is how we can locally access the training data. Maybe we can just use Flower dataset, and there will be one-liner. Except no, the data is generated on the smartwatches and synchronized to Huawei Health, from which we will need to access the data using Huawei Health Kit API or Apple Health Kit API. And this is one of the challenges. Their APIs are not really good to use. Then we have the data on the app. We pipe them into our federated learning SDK, and the derived data, such as parameters, are sent to our backend. This means that we need to make an app, and mobile development is also a huge burden. In this app, we need to do several things. This app is the way we access local training data on the smartphone. It needs to be cross-platform. That is, we support both Android and iOS. To do this, we chose Flutter. And so far, it has been a good choice, plus the nice UI library they provide. The second question is, how do we train the models on the cell phones? Initially, we thought it would be easier if we use a federated learning service. So we found a company and tried to integrate their SDK into our app. But it turns out the way federated learning services work is they send the data to their servers, which is a deal breaker because it doesn't pass the IRB among other reasons. So we turned around and looked at open source solutions, and obviously we found Flower. On top of Flower, we built FedKit, not to be confused with FedKit. In short, what it does is it trains the model across Android and iOS through this pipeline, and it does machine learning operation in this case, which it basically means it trains the model, it trains the latest model, deploys them without needing to update the app. This is done with Django and Flower. Check out our poster downstairs, by the way. And in this process, I was fortunate to contribute the new Android example and iOS bug report upstream. This one is merged, and this one is solved like 2 days later. Props to the Flower team. The third challenge is when to train the models. This question might be a bit more surprising, but it comes from the reality that the users control their smartphones, not us. What Gboard did and everyone was looking at was they trained the model when the user's phones are idle, but it didn't work for us because the background jobs we implemented did not run. After asking some people from the industry, we got to know that many versions of Android don't comply with the spec, and they just don't run the background job. So instead, we have to do some workaround, which is tell the user to leave the app open for 5 minutes a day. This also brings us to an important takeaway. That is, if you are not Apple or Google, you probably need to do this. So that pretty much sums up all the challenges we have in implementing federated learning in FedCampus. I hope this has been helpful. Thanks.
Thank you both for the great talk. We can take one very quick question. Does someone have a quick question? Yeah, at the front.
Thank you for your presentation. So my question is, which kind of model you implemented on the smartphone, and yes, which kind of model? Which is the complexity of the model? Thank you.
So, thank you. Thanks for your question. For the facial learning on smartphones, so we deployed a very simple, like sleep efficiency model. So with the training data set from our users' sleeping data, and also because if you want to give a sleeping efficiency score, so not only the sleeping hours, but also some other kind of data, so you can initiate like a simple linear model, so based on some of the data. For our facial learning model, so we just deployed a very sort of a simple linear model. Yeah.
Thank you. Thank you.
Yeah.
Great, that's all the time we have. Thank you so much for telling us about FedCampus.
Thank you.